This is Physics 275 lab. Our lab today is called the ideal gas law. Today we'll be using this container of gas at a fixed volume attached to a barometer. As we place it in different temperature water baths, our pressure will change. We can then record this data and use it to find other values such as the number of moles in this container or an experimental value for absolute zero. In conjunction with this video, there is going to be a lab guide PDF whose link will be in the description. Now we're going to show our tools that we're going to use for this experiment. I'm going to go to this camera and we're going to see we have calipers, we have a thermometer, a ruler, and our container attached to a barometer, and then of course our water bath. The first step of this experiment is going to be finding the volume of our container of gas. Put these to the side and go to this camera. And we're just going to let the calipers roll down. Now we take our ruler and line up the edge of our calipers, and now we have the diameter of our sphere. We can divide this diameter by 2 to get the radius and use the volume of a sphere equation to find the volume of our gas container. The second step of our experiment is to place the barometer with gas container in different temperature water baths. As the temperature of the gas changes, the pressure in the container will change because the volume is constant. We can then record the pressure values along with the temperature that we will use in later steps of this lab. Our third step is going to be using our values to make a graph of pressure times volume as a function of temperature. Using the slope of this graph, we can then find the number of moles of gas inside of our container. A graph of this is going to be shown in the following Logger Pro screen capture. The next graph we're going to make is temperature as a function of pressure times volume. The y-intercept of this graph will give us our experimental value for absolute zero in degrees Celsius. The fifth step is our error calculation. We will be finding the margin of error around our experimental value for absolute zero.